Welcome back. The objective of this video is to investigate even degree and odd degree polynomial functions, and we will also take a look and introduce end behavior of polynomial functions. Here in example 5, in problems 1 and 2, we have two even degree polynomials. In number 1, we have a fourth degree polynomial. 4 is even, so that is an even degree polynomial. And in 2, we have a quadratic, or a second degree, also another even degree polynomial. Well, what do you notice about the end behavior of those? Meaning, what do you notice about what happens as those to those graphs as x approaches positive infinity and x approaches negative infinity? Well, hopefully you notice that the end behavior of those is the same. They go in the same direction. And that is a characteristic of even degree polynomials. Their end behavior is in the same direction. So let's take a look at sample 1 here. We have this polynomial x to the fourth minus 3x cubed plus 4x. And let's find and explore the maximum and minimums here and find those values. And then let's talk about the left-hand behavior, meaning what happens as x approaches negative infinity, and what happens to our function with right-hand behavior, what happens to our function as x approaches positive infinity. So I've grabbed my graphing calculator and I've input the function x to the fourth minus 3x cubed plus 4x into the y equals, and I'll go ahead and graph this. And I'm going to just graph it in the standard window. So I'll go zoom standard, and there's the graph of our function. It mimics what we have on our sheet here. And we want to find these minimum and maximum values. So we'll use our calculator to find the local minimum. And actually this first minimum here on the left-hand side is an absolute minimum because we don't need y values that go any lower than that. We've got a local maximum in the middle, and it looks like this intercept here is another local minimum. And you'll want to note when the function is increasing or decreasing, increasing, decreasing, and the concavity and the turning points, all important concepts that we've studied there in this particular graph. We are asked to find the local minimums and maximums, so I'm going to start here with this minimum on the left-hand side, and we'll go to second calc. We'll do our left bound, we'll do our right bound, and we get our answer for an x value of 0.593. Our local minimum here is also an absolute minimum at negative 1.623. Continuing on, I'm going to find this local maximum here. So again, second calc, we'll do the local max, our left hand bound, our right hand bound, and we find that is 2.079 or 2.080. And for the final local minimum, which might be C in your notes, I suspect that is an x-intercept. We would do the local minimum process again, but I am going to do a quick review of x-intercepts. So we'll see if that is a 0, and we want to calculate the 0. So we do a left bound. So I did 0, left bound, right bound, and sure enough, we do have a 0 at 2. So the y value here is 0, so that is going to be the local minimum will be 0 at that particular point. Going back to our graph here on our notes, I've written in our minimums for point A is y equals negative 1.623. Our maximum at B was y equals 2.080, and our minimum at C, our local minimum, was y equals 0, that was also an x-intercept of 2, 0. Our left-hand behavior, as x's are going more and more negative or proceeding to the left, our graph is heading towards positive infinity. So we'll call that positive infinity for our left-hand behavior. And then our right-hand behavior also is positive infinity. And as we said, with even degree polynomials, our end behavior is the same for both left hand and right hand. I will let you do sample 2 on your own and bring that to class, and we will move down to example 4. I'm going to let you do 3 on your own and bring that one to class. In problems 3 and 4, we have 2 odd degree polynomials, and you should notice the difference between the odd degree and the even degree polynomials. The odd degree polynomials go in opposite directions. Even degree, same direction. The end behavior of an odd degree polynomial is in opposite directions. So we'll do sample 4 here in the video. We'll find our relative minimum point here at A. We'll find our relative max at B. I've already given that away. So A is going to be a relative min, and B is going to be a relative max. We'll put this information to our calculator. We'll hunt those down and fill in those answers. Let's take real quick, since we've got this here, at our left-hand behavior in this odd degree polynomial. Our left-hand behavior is going to positive infinity, and our right-hand behavior is the y values are going to negative infinity. I have put the function for question 4 into my calculator, -1/2 x cubed plus 4x plus 1. We will go ahead and graph this in the standard window, and we get a nice looking graph that mimics exactly what's in our notes. We'll get our minimum point here, second calc. That's a relative minimum or a local minimum. Get our left-hand bound, our right-hand bound, and our minimum is -3.355. And then we'll zip over and do our relative maximum, our left-hand bound, and our right-hand bound. And our maximum is at a y value of 5.355 and an x value of about 1.633. Fill in our answers. A is a relative minimum at a y value of -3.355, and B is a relative max of a y equals 5.355. And our left-hand behavior goes to positive infinity. Our right-hand behavior goes to negative infinity. I'll leave problem 3 for you to complete on your own and get a little practice and bring that to class. I do ask you to take a look at these, both the even in degree and odd degree and behavior, and what do you notice about the differences in those? See if you can make a connection between the coefficient on that leading term in each of those polynomials and that end behavior. And we'll get some more practice with this when I see you in class.